Hardware to Save a Planet explores the technical innovations that are giving us hope in the fight against climate change. Each episode focuses on a specific climate challenge and explores an emerging physical technology solution with the person bringing it into reality. I'm your host, Dylan Garrett. Hello and welcome to Hardware to Save a Planet. We get to talk today about long-duration grid energy storage with Claudio Spadacini, the founder and CEO of Energy Dome. Grid energy storage is a key enabler in our transition to clean electricity generation. Renewables like wind and solar have ups and downs that don't line up with energy demand fluctuations, so we need storage to even out the supply. This has been front of mind for many of us in California during this recent September heat wave here, as the state has had to enforce blackouts and other emergency measures to reduce demand in the afternoons as our solar farms stop producing. So this is a very timely topic. Energy Dome's technology uses compressed CO2 to store energy, and it looks really promising in terms of some of the key metrics like efficiency, cost, and lifespan. So I'm excited to learn more about it. I'm also really excited to get to know Claudio better. He's an engineer with a track record of developing disruptive technologies to combat climate change, and he's an entrepreneur. He's responsible for what looks to me like several careers worth of technology inventions and businesses founded in the climate tech space, including Exergy, a company focused on heat to electricity using Claudio's invention of the radial outflow turbine, and a company that drills tunnels in rock for hydroelectric power plants. So welcome, Claudio. It's an honor to have you. Thank you very much for being on the show.
So thank you very much, Dylan. So it's a great pleasure for me to be, this podcast. And thank you very much for inviting me. It's a great opportunity to speak about Energy Dome and our technology, the CO2 battery that we are very proud of.
Awesome. I appreciate that and looking forward to the conversation. I'd love to start actually just hearing more about your background and your path to climate tech and any major inspirations that got you here.
Yeah, thank you. So I'm a professional engineer as a background with 25 years of experience in the energy sector. I started my career back in 1995 in a startup company which developed gasification technology for municipal solid waste to produce synthetic gas and hydrogen out of municipal solid waste. It was an high temperature oxygen gasification process. I spent almost 5 years there. We built a plant over, around the world, in Japan, in Germany, and other places. A great opportunity to learn how to establish a brand new technology and a brand new, quite sophisticated process. Then I spent several years in the gas turbine and combined gas turbine sector. And then in 2008, I started my first company, SEBIGAS, a company which developed a technology for biogas production from organic waste and energy crops. We deployed almost, more than 80 plants around Italy, Europe, but also in Far East, in Thailand, and also in Brazil. And then in 2011, I started Exergy, the company which you already mentioned, a company which developed a brand new technology for radial outflow expander used in organic ranking cycle. And Exergy has been able to deploy more than 500 megawatt of geothermal plant, ranging from 10 to 25 megawatt each. This has been a great opportunity. And I left Exergy in late 2019, and together with my former CTO in Exergy, Dario Rizzi, and my former business development manager, Francesco Oppici, which are my co-founder, I started the Energy Dome. So we started operation in February 2020, 1 week in the office, and then back home due to COVID. And then we had a lot of time just to engineer, our first system, which you see in the background, which is our first commercial plant that is now up and running. So very proud that we've been able in less than 2.5 years to start from a vision, from an idea, and convert that into reality, which is a plant, which is not a demo. is a commercial plant which operates daily in the Italian grid and has demonstrated a technology that we feel very confident we will be able to deploy commercially in the next month. So we are quite fast track.
That's amazing. And yeah, incredible speed to get to that point. Before we get deeper into Energy Dome, I'm just curious because you have such a diversity of kind of innovations and businesses and places you've made an impact in climate tech. I'd love to know, what's your process? Do you start by looking at problems in climate change challenges, and then look for technology solutions? Or do you start with the technology? Or how do you go about it?
Thank you for this question, because it's very interesting and I can get this question from many corners. From a business perspective, I would say that, let's say, the actual space, so the actual market, which is energy storage, is not really by accident. I was looking for a market which, let's say, with a potential big market, because I spent the last 10 years in the geothermal. I feel we did everything very, very well. We have been able to, let's say, to develop a very strong technology, but geothermal is just difficult. It takes time to be developed. It is very difficult to be standardized. It is very difficult due to the geological risk, and it's very difficult to get scale due to, let's say, geothermal will never get access to low cost of capital. So I said, next challenge, the next company I want to try to start is a company that has to participate in a potential big market, like solar, like wind. So when I heard about, let's say, the energy storage, like the missing piece in the puzzle of energy transition, because there is no doubt that energy storage is the missing piece in the puzzle of energy transition, I said, yeah, I have to look into that. I have to try to see if I have some idea, and if I find out something to participate in that space. And this is the business perspective. From the other perspective, how to get, let's say, how to identify a good idea, how to participate in some space. My process is always to be, let's say, to try to challenge myself as fast as I can and try to destroy my idea as fast as I can. So I am something like, let's say, I'm following Karl Popper in terms of philosophy. So the best approach to identify a good and breakthrough technology, to me, is just to brainstorm and try to identify something. And as soon as you get the idea, try to destroy it as much as you can, as fast as you can. If you can destroy, you just succeed because you just save time. If you don't, maybe you have something good to work on, and go ahead. And every day, just trying to identify, let's say, a way to make it better, and the day after to destroy that idea. And then, if it can survive quite fast, you can just land to the right arrangement. And that is what we did, and together with my team, that is just working in the same way. So me with Dario and all the team of engineers, we are just brainstorming, putting together ideas, and then going through and very fast. So we have been able, let's say, to convert a vision into a real plant just due to this. And that's the way we used to. This is our secret, if you like, our secret sauce.
Yeah. Thank you for sharing the secret sauce. I appreciate it. Let's talk a little bit about if you could just kind of run through what the process is, what your technology does, kind of step by step, so people have like that baseline understanding of it.
Yeah, our process is a thermodynamic transformation, which is CO2. We store atmospheric, ambient pressure and ambient temperature CO2 into a gas holder, which is the dome, that keep the CO2 at ambient temperature and pressure. And from that, the compressor sucked the CO2 and compress it to about 60 bar, let's say, and the CO2, which is delivered by the compressor at 60 bar, is also high temperature because due to compression, the CO2 heat up and exit the compressor at about 350 degrees C, and then enter into a system which is a thermal energy storage, which cool down the CO2 from 350 to about 30 degrees by storing heat inside that thermal energy storage. After cooling down, the CO2 is liquefied by condensing and releasing the condensation heat to a water basin. This water basin is a kind of thermal energy storage, which is an ambient temperature thermal energy storage, which is just cheap, safe, because it's a water basin. No consumption of water, just store some heat. After that, the liquefied CO2, which is very high density and low volume, can be stored in very cheap, high pressure carbon steel vessel, pressure tank. And in that case, this is one of the main reasons why our technology is very competitive. That is that we can store a large amount of liquid CO2 in very small carbon steel vessels, which are very low cost and simple to be manufactured. In the discharge mode, we just follow the same way, the other way around. So we will evaporate back the liquid CO2 into gas by taking back the heat stored into the water tank. Then, after being vaporized, the CO2 goes back to the thermal energy storage, where the heat is released back to the CO2, which warm up to a temperature which is a bit less than the inlet temperature during charging. So it can be a bit less than 350 degrees. And then the pressurized CO2 enter into the turbine, into the expander, which produces the power, which is injected back to the grid. The total round-trip efficiency of the system is 75% at full scale, which is best in class, and I would say it is very close to the lithium-ion batteries efficiency, because even if lithium-ion batteries are higher in efficiency at the beginning, if you consider the full life cycle, end of life, normally lithium-ion batteries are changed when they reach 67, 65% efficiency. So as an average, are very close in the lifespan, which is between 3,000 and maybe someone say even more cycle, 4,000 cycles in their lifespan. The average efficiency is not far from 75. But together with that, we combine much lower capex and a lifespan which is in the range of 30 years.
Mm-hmm. You're using CO2, and when I first thought about this, when I first heard about this, I thought, oh, this must be sort of a carbon sequestration play. But it sounds like maybe it's just a coincidence that CO2 is sort of the villain in climate change so often, but in this case, it happens to have the right physical properties for your application. Is that the case, or is there some kind of carbon?
It's just the case. It is just ironically, let's say that the fluid, which is ideal to store energy because it has an excellent, let's say, thermodynamic behavior, and then is a very common fluid, is really non-toxic. Obviously, we have, and we could also use other gas like N2O, which has the same exactly thermodynamic behavior of CO2, exactly same. Unfortunately, that is a fluid which is a bit forbidden, let's say,
yeah.
in California, especially because it was used for other, let's say, use in the past. Yeah, but again, it's just ironically the same fluid which is causing the problem, which could be a solution for that. And in terms of embedded, let's say, emission, I'd like to stress a bit that our system, first of all, is done only by steel. Then we need some water, no continuous consumptions, just a first filling. And then we need just a first filling of CO2. So no rare earth material, no, let's say, rare metals, And that is a huge advantage. Then in terms of embedded emission, we have embedded emission which are much lower than lithium. And moreover, we aim in the future to charge our system with CO2, which is coming from direct air capture or maybe capture beyond the geothermal plant. So using this like, let's say, a negative. We want to start with a negative emission of CO2 in this system on top of the CO2 reduction that we will cause by storing renewable.
Interesting. Yeah, I was curious about this kind of, you mentioned round trip energy efficiency or total round trip efficiency, lifespan. There's sort of, I'm curious across all these metrics that are really important to this type of storage, how it compares to other options. I guess another thing that seems like an advantage is site specificity. So you could build this kind of, is there any restriction on where this could be built? Whereas some of these other options do have sort of site specificity, like I'm thinking pumped storage, hydro, or compressed air uses underground storage. How does that look for Energy Dome?
Our strength and the strength of our product, the CO2 battery, is that we are fully site independent, and moreover, very, very important, we are temperature independent, ambient temperature independent. It means that the system can work exactly with the same performances in summer in Texas or Arizona or in winter in Alaska. This is key to unlock the possibility to standardize, to deeply standardize the system. So we can exactly deliver exactly the same catalog, from the same catalog, the same product. We are developing one size of CO2 battery right now. The second will be available in 6 months, and then the next year we will maybe have a catalog of, I don't know, 5 or 7, let's say, different models, like a wind turbine OEM. So we compare us to a wind turbine business. So we wanted to offer, let's say, a machine and CO2 battery, which can be deployed exactly same in different areas. This is not only an advantage in terms of, let's say, supply chain, cost reduction, which is indeed a big advantage in terms of cost reduction and supply chain, but is also potentially a big advantage in terms of access to low cost of capital, which has been the key of success for solar PV and wind. So the issue that we have is decarbonization of the grid. And we can reach that target in 2 different ways, in my view. The first could be nuclear fusion, which in my opinion is good and will happen somewhere in time, but it's not tomorrow. It's definitely not tomorrow. The second solution is renewable, but there is the missing piece of the puzzle, which is the energy storage. So we need the energy storage. Okay, but we need the energy storage to produce base load green power. So if you look at our system, which is not, again, best in class on land usage, but we are very high efficiency. So if you look at the space you need to install the solar PV plant that you need to charge our system, is much small. Let's consider that we want to build a system which discharge, 20 megawatt for 10 hours. Having 75% efficiency, we need a solar PV plant which is 27 megawatt for 10 hours, for example. If you compare us, and that system is big, 25 megawatt, 27 megawatt of solar, how many acres or hectares? If you compare us with another technology like Quaise, which declares 60% in some cases, or Highview, which declares something like 50%, or Malta, which is something like, with other solutions which have a lower round trip efficiency, they need more than 50% more solar PV space that we need. And the space we need for the CO2 battery is just 8% of the space you need for the solar PV which charge our system. So in total, obviously, we are not the technology maybe which is best to be installed in the center of the city. But since energy transition is about a lot of deployment of solar PV plant and wind farm, and we need a lot of space to deploy that generation because renewable is, let's say, a distributed way to produce power. Inside that infrastructure, there is 10x the space. We need just 1/10 of the space or less to install the storage device, which are needed to transform that peaking generation into base.
Yeah, that makes a lot of sense. And maybe just the last way to look at it, I guess, would be in terms of levelized cost of storage, the levelized cost of energy storage. Is that a metric that's important to know when looking at this?
Yes, obviously, it is always those parameters are always very, very much dependent on the assumptions. So we have always to be, let's say, careful to say, including the cost of capital, which is not really, something which is marginal into that. So our technology, we want to achieve a levelized cost of storage, which is, let's say, below the 5 cents per kilowatt hour, 5 to 6 cents per kilowatt hour, based on the assumption that we will be able to deploy several dozens, at least, of units per year, which will allow us to get access to the right, let's say, capital. I think that this is just a process we are at the beginning. So we have been able in 2.5 years to have a commercial plant, which is not full size, but is 2.5 megawatt and 4 megawatt hour. Now we have already issued the purchase order for the turbo machinery for the full-size commercial plant, which is 25 megawatt and 200 megawatt hour. And we see that there is a plenty of potential opportunity. And again, we are bidding based on price, efficiency, and the lifespan. And we leave, let's say, our potential customer to run the business plan for their, let's say, case study. And the feedback we are getting is that there is, let's say, an incredible interest because they really see that with our technology, many projects which were simply not feasible are becoming very remunerative, potentially very remunerative. So this is the competition. So the competition is versus the business plan of projects which are not feasible today due to constraints into the available technology.
Right. Let's talk about the business model a little bit. It sounds like your plan is not to build and operate these plants yourself. You're selling to energy operators. Is that right?
Our business model is we don't intend to own and operate the plant. We intend to try to deploy in the market as much CO2 battery as possible, which are all identical, in order to get that scale into the standardization, which again will allow us to benefit from an economy of scale. And in this respect, I want to say we don't chase an economy of scale to become competitive. We are already competitive with the first of a kind. So the first of a kind CO2 battery, based on existing price of the shelf component, which we received from the supplier, result in a total cost, full EPC, fully installed cost of the CO2 battery, which is at least 30% less than lithium-ion battery today. Then, to economy scale, we are envisioning to reduce that cost and our price even further and very fast. When we reach an economy of scale of just 10 plants per year or 12 plants per year, our supply chain will be available to deliver at much lower cost and shorter delivery time. So this is very important. But there is another important parameter in that. As soon as we will be able to deploy several dozens of plants, also the cost of capital associated to that asset will be much lower. And this is a very, very important parameter because maybe 2 or 3 % difference on the cost of capital make the difference over 30 years. So this is, we are concentrating ourselves on this, and we see our customer in company like large IPP or utilities We are bidding quite a lot of projects. Let's say right now, also in the US, we are just trying to enter into the US market. This is our approach.
On the technology side of things, where have you had to innovate? It sounds like you're able to use a lot of existing supply chain and off-the-shelf compressors and things like that. Have there been any big kind of technical engineering challenges you've had to overcome?
So we have, I think that the process itself that we have identified has a lot of features. The control of the process has a lot of features. The detailed design of all the components have been, done very successfully, we can say, because now we have all the tests and report also from third parties of the working plant. So we have been able really, to vessel, heat exchangers, compressor and expander, valve, piping, electrical motor, everything exists, but you have to make them to match in the right way. And we have plenty of intellectual property application because we have identified a new process, which is proprietary, new control of the process, which is proprietary, and a way to combine the component and to design the component to realize that process, which is proprietary and is working really very successfully. The strength we had is that we have been fast and being able to achieve that point in just 2.5 years. And now we have a technology which is working commercially, is protected, is proprietary, and has a very huge potential that start from very competitive cost, but through economy of scale and penetration in the market can achieve extremely low cost, keeping very high efficiency and long lifespan. That's the itinerary that we have in front of us. We see in the US and North America a very nice, opportunity that we can, and we want to be there. We just raising additional money. We are in capital rise mode because the company is growing. The company is really going fast.
What do you think Energy Dome will look like and I don't know if it's 5 or 10 years out, like when you kind of get to that steady state vision, what does that look like?
So my idea and the target, the dream is to have, the dome to be the icon of the energy transition in space. If you Google, right now, renewable energy, you see a three-blades turbine. That is the symbol of renewables. I think that, we aim to be impactful. We aim to be everywhere. And we aim to have, the dome, which is quite an icon, to look like, an iconic symbol of the energy transition. To be that missing piece in the puzzles of the energy transition.
That's awesome. I have to say, and we'll put some links to pictures of everything because it is a really iconic kind of design and visual. I love the dome. And I also love that it has a tie to your background in biogas. It's really interesting how those things kind of tie together. Is it, just quickly on that, is it important that it's a dome? Like mechanically, does it serve a certain purpose as that dome shape?
It's important because it's cheap, is very fast to install. We can install this in a few days. It is relocable, fully based on prefabricated and a renewable foundation. So if you have to move, it looks like we use 4 hectares for a plant. But if we have to dismantle, all the foundation of the dome are just relocable, pre-assembled and prefabricated, so no problem. So it's a smart solution. It's cheap, it's safe, and it's a symbolic, I have this feeling and also talking to people that, the new generation really take care about the environment, about the pollution. And if you have something which is also visible, but that is important, is impactful to make the world greener, this will be accepted by the new generation. So if it is big, it's not important. It is what is there for, and is there for producing base load green power. And that is something that the young generation just understands. I heard a lot of, let's say, bad words about the wind turbine in the past. Let's say here in Europe, a lot of people against due to visual impact. Now there is no one in the new generation which take care about that. Okay, this is a wind turbine. This is green. This is good, and that's it. So I feel that when I speak about, let's say, an icon in that energy transition, is because we need to recognize which are the technology, the asset which can enable that transition. So, and I feel that the dome could be one of those.
Yeah, I love it. You mentioned fusion earlier. Do you think there's a future, and I don't know how far out it would be, that we don't need energy storage like this because we have some clean, renewable baseload energy like fusion or geothermal or something?
I think that the progress, the innovation, now there is an incredible deployment of not only capital, of, let's say, good people, which is trying into that sector. And so I have, let's say, I don't think that there is a reason why not to succeed. It is quite a long path because, again, simplicity is the arrival point. And at the beginning, nuclear fusion is not simple because you have something like 4,000 degrees C or 5,000 degrees C to be contained in a space. It cannot be done simple. And I think that it's just a matter of, it will take some time. I feel quite a long time, but I don't know. My opinion is just that, now the transition is really urgent, because the decision has been taken. All the financial institution doesn't deploy any more money to people which wanted to invest any more in coal or things like that. And the transition is just urgent, and we need to give answer now. And the CO2 battery is a solution today. Nuclear fusion has to be, let's say, can be a solution in 20, 30 years. That's as an engineer, I like to build up my opinion. I spent some time to look into the different nuclear fusion technology to build up my opinion, and this is my opinion.
If there's anything I've learned talking to everybody about climate change, and it's that we don't have time to wait. We need solutions now, and it sounds like you've optimized for that in a really, really smart way. So that makes a lot of sense. I think that's a good transition to last few closing questions. How optimistic or pessimistic are you about the future of our planet, and why?
I'm a bit skeptical about the real capability to get to the target which have been set by 2030 and 2050 to be very realistic, but it's also worth to have, let's say, targets which are a bit beyond what I feel are the real target. I feel that to get there, we really have to be very, very straight, and we just need to deploy renewable and long duration energy storage. And this is quite frankly, obviously I have an interest in that because, I believe that we have the right technology, but I don't see any other, let's say, possibility to get the transition to happen. On the other side, I'm positive because I really see that all the world is moving really fast track in that direction. All the financial institutions are putting a lot of money and a lot of effort. And I really feel that we are in an acceleration phase. And I'm quite positive. I feel that we will not get to the target, but we could be close if we don't lose time.
Who is one other person or company doing something to address climate change right now that's inspiring you?
I don't want to mention, a specific company or a specific. There are a few which I have in mind, which I really like, but I wouldn't like, let's say, to mention, one or the other.
Sure.
I just think that there are incredible, let's say, investors which are putting money and which are taking some risk. Is even in this, let's say, moment in time where the financial markets are very difficult. I see a lot of investors which very much interested to support those verticals like us, long duration energy storage, or like hydrogen, which are the main verticals that have to be financed to find a solution to accelerate the transition.
Yeah, that capital is really important. The last question is, what advice do you have for someone who's not working in climate tech today who wants to do something to help?
Is to try to be really impactful and just to think, to think big, because everything is changing and the transition is really deep and is really something which is going to change very deeply, the way we are doing things. And the only way to make impact is really to think big. So we have to try to get something which is really 5x better than before. And I always like to demonstrate that the circle is round. So I never accept from anyone that by definition that is like this, just to challenge everything, which is maybe just said, okay, this thing has to be like that. Just try to find a new solution or understand why it's done like that. And if you understand why it's done like that, then maybe you find another way to do it, which is better.
I love that. Think big. And I think you're setting a really great example of doing that yourself. Claudio, I really appreciate the opportunity to talk with you. I learned a lot today and I'm inspired by what you're doing. Thank you very much.
Thank you very much, Dylan, for the opportunity. It was great to talk today. Thank you.
Hardware to Save a Planet is brought to you by Synapse. To find out more about us and how we develop hardware solutions for the world's most ambitious companies, head to synapse.com. And then make sure to search for Hardware to Save a Planet in Apple Podcasts, Spotify, and Google Podcasts, or anywhere you like to listen. Make sure to click subscribe so you don't miss any future episodes. On behalf of the team here at Synapse, thanks for listening.